So we're continuing to talk about how to solve a logarithmic equation, and this is the kind of the second guideline I like to follow. If I have a log on both sides of the equal sign, then I can use a one-to-one property to solve. So if I have a log on the left and a log on the right, then I use this one-to-one property. It says that if I have log base a of x equal to log base a of y, then I can just set those arguments equal to each other and solve, but they had to be the same base. If I have log base a of x equals log base b of x, then this time we just set their bases equal to each other and solve. They had to have the same argument in this case, and in this one they had to have the same base. If that's the case, we use the one-to-one property to solve. So we have two examples that we're going to look at here. The first one says log base 5 of 2x equals log base 5 of 12. We can see that both logs, there's only two of them in the equation, and both are the same log 5s. If that's the case, we take their argument, 2x, and we set it equal to the argument on the right, and that gives me 2x equals 12, so x is equal to 6. Pretty straightforward again. Let's look at this example. This one says I have log base x of 7/3 equal to log base 2x minus 3 of 7/3. The argument in each of these logs is 7/3. Since the argument in both cases is the same, we can take the base of each log and set them equal to each other. So x is equal to 2x minus 3. Gather your variables up on the same side, so I am going to subtract x to the left-hand side, I guess, and I'll get negative x is equal to negative 3. Divide both sides by a negative number, and I get x is equal to 3. And that's how we are going to use this one-to-one property when I have logs, only two logs basically, or logs on both sides of the equal sign is another scenario.